Welcome to the lesson Cuboids and Cubes. At the end of this lesson, you will be able to define cuboids and cubes and derive the formula to calculate the surface area and volume of cuboids and cubes. Let's look at the objects seen in these pictures. Each of these objects have 6 faces that are rectangular in shape. Such objects are called cuboids. Now, if you look at the faces, the top and the bottom faces are parallel to each other. These are called the bases. The remaining 4 faces that join the 2 bases are called lateral faces. Cuboids have 8 vertices and 12 edges. The edges of this cuboid are its length, breadth, and height. Now, let's look at another figure. Here, the length, the breadth, and the height are all equal. Such a figure is called a cube. As you can see, the basic difference between a cuboid and a cube is the shape of their faces. A cuboid has rectangular faces, while a cube has square faces. These figures are also known as prisms. Let's look at a practical problem. You want to put up wallpaper in your room. To estimate the number of wallpaper rolls required, you'll need to know the area of the 4 walls. As you can see, the room is cuboid in shape. The 4 walls of the room represent the 4 lateral faces of the cuboid. If we add the area of the lateral faces, what we get is called the lateral surface area, or LSA, of a cuboid. Now, let's derive a formula to calculate the LSA of a cuboid. To calculate LSA, we have to find the areas of the 4 lateral faces. As each lateral face is a rectangle, we can apply the formula length into breadth to calculate the areas. We get the areas of each lateral faces as LH, BH, LH, and BH. Now calculating LSA is easy. All you need to do is add all these areas. On simplifying this expression, we get the formula as 2 times the height multiplied by the sum of the length and breadth. Let's rearrange this formula. Here the expression twice the sum of length and breadth is equal to the perimeter of the bases. Hence, we can also define the lateral surface as the product of perimeter of the base and height of the cuboid. Using the formula for LSA, we can derive the formula to calculate the LSA of a cube. In the case of a cube, all its edges are of the same length. Let's assume it is A. Substituting A in place of L, B, and H, we get the formula as 4A square. Consider a different situation where you have to paint an overhead water tank. In this case, you will need to find the total surface area, or the TSA, of the tank. Please note that the tank is cuboid in shape. The total surface area, or TSA, can be defined as the sum of the lateral surface area, or LSA, and the area of the 2 bases. Please note the areas of the bases are equal. That is, equal to twice the length into breadth. We have already derived the formula to calculate the lateral surface area. We'll now substitute these in the equation and simplify it. Please take note of the simplification steps displayed on the screen. We can use this formula to derive the formula for TSA of a cube. In case of a cube, the length, the breadth, and the height are equal. Let's assume these are A and substitute it in the formula. We get the formula for TSA of cube as 6A squared. Let's consider the water tank once again. How will you determine the quantity of water that can be stored in the tank? By quantity, we mean the volume or the capacity of the water tank. Let's first understand the meaning of the terms volume and capacity. The space occupied by an object is defined as its volume. Now, if the object is hollow, its inner space is empty. The empty space can be occupied by air or it can hold some liquid. The volume of substance that can be stored by the object is called its capacity. Both are measured in cubic units. Now, in case of the tank, if its length, breadth, and the height is known, then we can derive the formula to calculate the volume of the tank. Let's imagine the water tank is made up of H number of rectangular sheets. The space occupied by one sheet, or the volume of one sheet, is equal to the area of a single rectangular sheet. Similarly, the volume of H sheets will be H times the area of a single sheet. The height of the tank can be represented as H, and the area of one rectangular sheet represents the area of its base. Therefore, the volume of tank can be represented as length multiplied by breadth multiplied by height. As the tank is cuboid in shape, we can generalize this formula for the volume of a cuboid. In case of a cube, all its 6 faces are squares. Therefore, its length, breadth and height are all the same. Let's assume it is A. Substituting A in place of L, B and H in the formula, we get the volume of a cube as A cubed.